In the world of electricity and power, efficient distribution has always been a major challenge. The traditional power distribution systems we've relied on for decades have some significant drawbacks. One of the biggest concerns is energy loss. As electricity travels over long distances, a considerable amount of power is lost due to resistance in the lines. Moreover, these systems lack scalability, making it difficult to meet the growing demands of our modern, electricity-hungry world. And let's not forget the dangers of high voltage. High voltage transmission raises serious safety risks, from electrical fires to life-threatening electrocutions. These issues are not only inconvenient, but they can also lead to power outages, increased costs, and safety hazards. They are systemic problems, deeply rooted in the traditional power distribution model that have been plaguing our electricity-dependent society for far too long. But what if there was a solution to these problems? Enter the world of transformers. Transformers, not the movie franchise, but the real-life heroes of our power grids, have been quietly revolutionizing the way we distribute electricity. Have you ever wondered how electricity travels from power stations to your household appliances without causing a catastrophe? The answer lies in the heart of these unsung heroes, transformers. These devices play a crucial role in converting high-voltage electricity to lower, safer voltages for our day-to-day use. At its core, a transformer is a simple device comprising two primary components, a magnetic core and windings. The magnetic core, often made of iron, provides a controlled path for the magnetic flux generated in the transformer. The windings, on the other hand, are coils of wire wrapped around the core. When electricity passes through the primary winding, it creates a magnetic field that induces a voltage in the secondary winding. This is how a transformer steps down high voltages to lower, more manageable ones. The generation of transformers is a meticulous process, requiring careful selection and assembly of these components. The magnetic core must be highly permeable and low in hysteresis loss. The windings, typically made of copper or aluminum, must be properly insulated to prevent short circuits. What's more, transformers aren't a one-size-fits-all solution. Different types of transformers are generated for different applications. Power transformers, for instance, are used in transmission networks for stepping up or down voltages. Distribution transformers, on the other hand, are used for lower voltage distribution, making them ideal for domestic use. And then we have instrument transformers, designed for specific applications like metering and protective relaying in electrical systems. The design and manufacturing process of each type of transformer is adjusted accordingly, ensuring they perform their intended functions efficiently and safely. From the choice of materials to the number of windings, every detail is fine-tuned to meet the specific needs of the application. So, as you can see, the generation of transformers is a complex yet fascinating process. They might not be as glamorous as their Hollywood namesakes, but when it comes to keeping our world powered up, these real-life transformers are the true stars. Now that we understand how transformers are generated, let's explore their impact. Transformers have revolutionized the way we distribute power. By stepping up or stepping down the voltage, they've significantly reduced energy loss during transmission. This, in turn, has made power distribution more efficient, more scalable, and safer. They've become an integral part of our power grids, ensuring that electricity reaches our homes, businesses, and industries with minimal loss. They've made it possible to distribute power over vast distances, from the power plants to the most remote locations. And it's not just power grids. Transformers are everywhere. They're in our electronic devices, enabling them to run on the varying voltages supplied by our power outlets. They're in our electric vehicles, converting the high-voltage battery power to a lower voltage that the vehicle systems can use. They've even found their way into renewable energy systems. In solar power systems, for instance, transformers are used to step up the voltage produced by solar panels. making it suitable for transmission over power lines. Without transformers, we'd be dealing with much higher energy losses and safety risks. We'd also be more limited in our ability to scale up power distribution to meet growing demand. So, the next time you switch on a light, charge your phone, or drive an electric car, remember the humble transformer. It's quietly working in the background, making all these things possible. Without transformers, our modern world of electricity and power would look very different. Transformers have truly transformed our world, no pun intended. Pause for a moment and consider how your daily life is influenced by these technological marvels. From powering your morning coffee maker to the device you're using to watch this video, transformers are everywhere. So, what's your take on the role of transformers in our modern world? Share your thoughts in the comments below, and don't forget to subscribe for more intriguing insights into the world of tech.